Hello, I'm Mike, and welcome to watch my video. This video combines my previous shared 5 videos and provides a comprehensive solution guide on how to implement Power BI dynamic security solutions using DAX. In part 1, you will explore a way to build dynamic low-level security RLS using DAX, setting up foundational protections. Part 2 introduces an objective-level security OLS approach implemented through the Tabular Editor external tool for added granularity. Part 3 introduces an alternative approach to build a type of OLS which combines low-level security RLS and column-level security CLS using DAX alone, without external tools, enhance flexibility. Finally, Part 4 and Part 5 dives into advanced techniques to refine and expand combined RLS and CLS with DAX, accommodating more complex organization hierarchies for robust, scalable data security. Okay, let's get started now.
Hello everyone, Mike is here. By today's video, I shall demonstrate a way to create Power BI low-level security for organization hierarchy. Hope you like the video. Okay, let's get started. First, let me describe you the business scenario in this video. The screen presented organization chart is quite common thing in our daily life. For example, we have the 3 layers organization, 2 manager level and 1 employee level. Manager AA has 2 subordinates directly reported to him or her, and also has 4 subordinators indirectly reported to him or her. What we want Power BI low-level security RLS to do for us is to restrict the certain level employees can only view his or her subordinators info and his and her info as well. Means that manager BB can only view his or her info and his and her subordinators info from the report. Same case apply to manager CC as well. Employee without subordinators can only see his or her info. For realizing the setup, we shall apply 2 Microsoft DAX functions in my video. Because Microsoft experts have categorized well such hierarchy scenario by their parent-child definition with some functions. One is a path and another one is path contents. To find and understand these 2 DAX functions, we can Google the related contents from the Microsoft Docs website. In the section of understanding function of parent-child hierarchies, the MS Docs gives the descriptions on how the parent-child case can be presented in a table with 2 key columns. For example, parent-child hierarchies can be represented in the employee key column and the parent-employee key column of a table, such as employee 81 has a parent 162, who has a parent 3, and who has a parent 14, who has a parent 112. With the representation, the MS created path function actually help us to find the lineager from the 2 columns. For example, child 81, lineager tree from the right to the left is 81 to the 162 to the 3 to the 14 to the 112. This lineager info is key info for hierarchy security control. Another important function is path contents, which can help us to judge if a specific employee exists in a lineage extracted by pass function. For example, with the true indication returned by the pass contents function, that 162 exists in two rows of the pass. Now we know the pass contents and the pass functions are the two key functions for our scenario and should be understood quite well before our next steps to create the RLS. Let's start to create the RLS for the hierarchy in Power BI. I have the Power BI desktop file which has two tables in the table view. One is a dimension table, employee hierarchy table. Another one is a factor table regarding the sales info by each employee, such as employee name, employee ID, sold product, price, customer, date, quantity, etc. Move to the data model view. There's two tables linked by employee ID in the data model. With these created tables, data model, and measures, we have generated four charts in the report visualization for measuring the sales performance by employee. Such info is sensitive to employees themselves. Thus, we should apply IRS to limit their view to access the report info according to the organization hierarchies. To create the low-level security in Power BI Desktop, let's first apply the DAX function in the employee dimension table to find the entire lineage. Click the new column, name the column as hierarchy path, type path and choose it. In ID column name position, select the employee ID column. In the parent column name position, select Manager ID column. Then bracket. Click the tick to evaluate the DAX formulations. Now we see the path returned lineage for each row. Now we need to create the DAX field function by applying the path contents. To build the DAX field, I first created the new column in the dimension table, gave the column name, then type path contents, select the column hierarchy path, then type example ID 1002 in, then evaluated the DAX formula, working as expected. Now I need to find the employee ID by look up the employee email address instead, because access identifier and the cloud will be user email address. We shall use the lookup value function. We look up the employee ID column. As a mapping condition, we should have the request email address to be mapped to our employee email address column. Evaluated the DAX formula and the column returns the same result because the 1002 email address is cctest.com. Now we reached a key step here. Copy the DAX field function and go to the visualization view. Click the Manage Rows. Click Create button. Name the rows. Select the employee hierarchy table as a field table. In the table field DAX expression, paste the copied DAX formula. Replace static email address by the dynamic user identifier, which is user principal name. Now the RLS for hierarchy is ready on the Power BI desktop. Let's do some tests before publish the desktop to Power BI service. Place cctest.com email address in the view. Then he or she is able to see his and her subordinator's info, and his and her info. Do another test. Place employee ggtest.com email address in, and he or she is only able to see his and her info. Place aatest.com email address in, as he or she is top manager, and he or she is able to see all info of his and her subordinators. Now it is ready to publish desktop to Power BI service. After publishing, we need to do two setups on the service side. First, the setup is on the report dataset level. We need to add the valid employee email address into the created RLS roles group. Second setup is to add the valid employee email address into the workspace access list and define the role as a viewer. Then save and done. You may create the report app and the created RLS will be active there if you share the app link to users. This is all about the steps regarding creating Power BI RLS for hierarchies. Thank you for your watching and see you in next video. Object-level security enables module authors to security specific tables or columns from report builders. More specific benefit of the OLS compared to RLS can be referred to the attached URL link of Microsoft Power BI blog. Currently, OLS definitions are not created natively in Power BI desktop. But external tools such as Tabular Editor can set OLS rules on Power BI desktop dataset. Embed Tabular Editor applications in Power BI is simple. By Google search Tabular Editor free download, find and click the website Tabular Editor SQL BI site, download and install it. Once complete the installation, the Tabular Editor will be added in Power BI desktop under External Tool menu. To create OLS, the first step we need to create the role in desktop report view. Choose Modeling in top menu bar. Click Manage Roles. In pop-up window, we created two roles. The first one is OLS column restrictions. The second one is OLS table restrictions. Click Save. On the External Tool ribbon, click Tabular Editor. In the Model view, select the drop-down under Roles. The created two roles appear. Select the OLS column restriction rule. Enable a OLS definition rule as none for the column profit of a table financials. Then select the OLS table restrictions rule. Enable OLS definition rule as none for the table financials. Save the OLS rules and close Tabular Editor. Save the desktop file. Let's have a testing by our created OLS rules. In the year-to-date summary table, we have a profit info. In the year-to-date charts page, we have a profit info in first and the fourth chart. In right side field panel, we also see the profit column in financials table and the profit year-to-date measure under the measures table. Choose Modeling ribbon. Click the button of the View As In the pop-up dialog list, tick the row OLS column restriction. The table chart shows errors to the viewer as it has a perfect info. Move to the year-to-date chart page. The first chart and the fourth chart shows errors to viewer as they have the perfect info. In right side fields panel, the perfect column disappeared in financial tables and the perfect year-to-date measure disappeared in measures tables. If we click stop viewing, all perfect related info return to life again in each table and chart. Repeat the same steps to check the view of the row OLS tab restriction. Then we find the row does not have any visibilities in report and the row is restricted to see any info from the financials table. To enable the OLS and the Power BI service, we need to publish the Power BI desktop file to the Power BI service. In the Power BI service, navigate to Workspace, find the Power BI dataset, select the More Options menu on the dataset, choose the Security. In the Security page, assign the members or groups to their appropriate roles, then click Save. A reminder here is if any of the assigned member or group has been assigned a permission before in the workspace, please ensure that they should have only the viewer permission to the workspace. The last step is do not forget to update the apps if you have the Power BI apps shared before. That is all in the short video. If you like to watch more videos from the channel, please press the subscribe button in below. Thanks for watching and see you in next video. Hello, I'm Mike. Some Power BI users asked if we have the Power BI combined row-level security and object-level security for end user to access reports and dashboard. For example, in an organization, some users can only see their own sales but not cost and profit, and other users can see their own sales, cost, and profit. For the requirement, I tried Power BI row-level security feature with external tool Tabular Editor OLS for a combined row. For example, in screen, I have the Power BI RLS sample file for organizational hierarchy in my previous video. In the file by Tabular Editor OLS, I have added the column level security to the row RLS hierarchy user group regarding the column cost and profit. My testing shows a message as unable to view as selected rows. The explained reason in detail is displayed in the message and also mentioned as Microsoft site stated that row-level security and object-level security cannot be combined from the different row. For reference, I attached the Microsoft site URL link in video description. After checking and reading related materials, especially the book Microsoft Power BI Cookbook wrote by Greg and Brad, you may refer to the reference URL link in video description. I found a column level security creation method and extended the method to combine row-level security and column level security by using Power BI row-level security feature with a modeling design. In my Power BI file, I have a 3 layers organization as example. First layer has 4 sales representatives. They are D, D, E, E, F, and G, G. Second and third layers are manager layers. They are AA, BB, and CC. I have created 2 roles in this file. One is RLS hierarchy user group, in which members can view their own organizational sales, cost, and profit. All managers are in this user group. Another role is combined RLS and CLS hierarchy user group, in which members can only view their own sales info but not cost and profit. All sales representatives are in this user group. I have created different bar, column, and table charts in 3 report pages. Especially in the table chart, we can see price, sales, cost, and profit values in corresponding columns. Let's place manager bb email at test.com in the role of the RLS hierarchy user group. By the view of manager bb, he can see all info of his team, includes info of himself. Let's place sales representative DD email at test.com in the role of the RLS and CLS hierarchy user group. By the view of the DD, he is able to see only sales values but not cost and profit. Compared to Tabular Editor OLS, by these methods, sales representative DD knows that cost and profit values are existing in the data model but not visible to him. In some situations, this kind of view visibility could be useful features in an organization. In rest of the video, I shall demonstrate the steps on how to create a combined RLS and CLS role for organizational hierarchy. The step 1 is design the column level security while data modeling by splitting the sales table original into sales table and cost table, in which the cost table includes profit values. In screen, the example Power BI file has the same data modeling design and low-level security setup as my previous video, RLS for organizational hierarchy. You may find the video from my channel. It has one dimension table, employee hierarchy table, one factor table, sales table original, and one measure table which hosts all created measures from this data model. In Data View, choose the Sales Table Original. Right-click the Edit Query. In Query Editor, on top ribbon, choose Add Column tab. Choose and click the drop-down list of index column. Then choose from 1. An index column is added in the end of the table. On the left side, right-click the Sales Table Original. Disable the Enable Load. Please continue to close the warning message. On top ribbon, ensure Home tab is chosen. Then in drop-down list of the new source, choose a blank query. Name the query as a sales table. Right-click on it and choose the Advanced Editor. In Editor, enter hash sign for the formula after source. Then choose Sales Table Original from the list table. Click Done. In Sales Table, remove all columns related to cost and profit. Again, in the drop-down list of new source, choose blank query. Name the query as a cost table. Repeat the previous same steps to query Sales Table Original. In the cost table, keep only the columns of index, cost, and profit. Control select both sales table and cost table. Right-click on them. In the pop-up dialog list, choose Move to Group. Click New Group. Name the group as Fact. Then in the left side, we see New Fact Query Group created, and 2 new created tables are moved into the query group. Click Close and apply the changes on query editing. Move to Model View. We see that a new data model is set up, and which includes the sales and cost tables plus existing employee hierarchy table and the measure table. And the sales table original is unloaded and invisible in the model view. The suggested relationships among these tables are rebuilt automatically. To enable the later CLS working, for the suggested relationship between sales table and cost table, we need to change the one-to-one bi-direction relationships to one-to-many single direction. One is at the sales table side and many is at the cost table side. This single cross-field direction is an important setup that allows us to apply RLS DAX function through the mapped index to show values of the sales table and at the same time hide all column value of cost table.
And this phase, the data model has been modified. We need to check and rebuild all measures which have been created based on the old data model for the visualizations in all report pages. Step 2 is create RLS and CLS combined row. After rebuilding all related measures, move to the report view. On top ribbon, choose Modeling tab. Click Manage Rows. Create new row and name it as RLS and CLS Hierarchy User Group. On the table list, choose Cost Table. In Table DAX field expression, enter the is blanket, open bracket, place index column in, close bracket, which tells if the index column value is blank. Then the DAX field expression returns true, otherwise false, which means that if returned value is false, this is our expected value. The values of the cost table will not be shown in visualization. Finally, it enables column level security control. To the new row RLS and CLS hierarchy user group, we still need to keep the RLS for organizational hierarchy rule as the existing RLS hierarchy user group. Copy the DAX field expression from RLS hierarchy user group and paste it to the employee hierarchy table DAX field expression field under the new row of RLS and CLS hierarchy user group. Save the RLS combined CLS row is ready for testing. Step 3 is test and publish it to Power BI service side to enable the security setting and dataset level and workspace access level. On top ribbon, under Modeling tab, choose View as. Tick on the RLS hierarchy user group and other user. Enter the manager BB email at test.com into the empty box of other user. Press OK. Then in table chart by the view of the manager BB, we see values of the sales, cost, and profit of his team. Check other page visualizations. We see that only his team's value are visible. Stop the view of the manager BB. Tick on RLS and CLS hierarchy user group and other user. Enter sales representative DD email at test.com into the empty box. Press OK. Then in table chart by the view of DD, we see only his sales related values are visible. Cost and profit columns are visible but with empty values. Check other page visualization, only his sales related info are visible. Now it is time to publish report to enable the combined RLS and CLS for end user and service side. We need to assign the list employee into the corresponding to security roles and dataset security setting, and also make sure those employees are viewer user group category. For detailed setting, please refer to my previous video, RLS for organizational hierarchy. Please let me know your comments or if you have other alternative solution for combined RLS and OLS setting. If you like to watch more videos from my channel, please press subscribe button in below. Thanks for your watching and see you in next video. Hello, I'm Mike. In most larger companies, we see their organization hierarchy structure mixed with solid and dot reporting lines. Such as in a sales organization, besides sales heads and sales manager, there are also the financial controller heads, pricing managers, and HR heads, etc. Some of them have the same sales info visibility as the corresponding frontline sales management team. For example, financial heads and financial controllers, they should have the same even more info visibility about sales, cost, and profit as the same level sales heads and sales managers. For such demands, we need to have the corresponding Power BI security control. In this video, I shall share an extended Power BI row-level security and column-level security setup for a mixed solid report line and dot report line organization hierarchy based on my previous video. Before the demonstration of creation, let me have a short brief about the creation concept with its logic steps. We first convert the mixed report line hierarchy into a consolidated table which has a one-to-one mapping between the solid line manager and the dot line manager by manager ID. It is also the employee ID. Then add manager name and email address in table as well. The key step of the approach is applying DAX function, lookup value, and path contents, etc. to transfer the parent-child lineage path from solid line manager to dot line manager by replacing solid line manager ID with dot line manager ID for all list sales employees. Based on the transferred lineage path and dot line manager ID, we can create the row-level security field index, which is used for new row table field DAX expression. Last step is creating new row dot line manager group and place the created field DAX expression in corresponding table field DAX expression field. Publish desktop file to service side. Assign related users to the user roles and dataset level and workspace access level. Now let's get started the creation demonstrations. Step 1 is to generate the mapping table between solid report line managers and dot report line managers in Power BI desktop file. In Data View, under Home tab, click the Enter Data. Name the tables as a solid line versus dot line mapping table. Then register the solid line manager ID, name, dot line manager ID, name, and the email address. Please load button. We have the mapping table created. Step 2 is create the table DAX field expression by transferring the parent-child lineage from the solid line hierarchy to the dot line hierarchy at manager level. In Data View, on right side panel, choose Employee Hierarchy Table. We need to bring the dot line manager ID by adding a new column to the table by using lookup value DAX function. In top ribbon, choose Table Tools tab. Then click the new column icon. In DAX formula bar, enter dot line manager ID equal to lookup value. Inside bracket, enter the looked dot line manager ID from solid line versus dot line mapping table by mapping solid line manager ID from solid line versus dot line mapping table against the manager ID of the current table. We have the mapped dot line manager ID list in the new column. For later table field DAX expression creation, we need to find the dot line manager ID for the top empty row, which should be the same level solid line manager's employee ID. Thus, we apply if function to check if any empty row in the manager ID column. We look up the dot line manager ID from the table solid line with dot line mapping table by mapping solid line manager ID from solid line with dot line mapping table against the employee ID of the current table. Otherwise, keep the previous formulated DAX expression for dot line manager ID. We have the dot line manager ID in table. With them, by using lookup value, we can bring the dot line manager email address into the current table from the solid line with dot line mapping table. Now in the table, we need to create the dot line linear hierarchy path column for all sales employees. My way for generating the hierarchy path is to replace each solid line manager ID of column hierarchy path by the corresponding dot line manager ID. To realize the idea, we look up the dot line manager ID from a table solid line with dot line mapping table as before, but this time against the identify solid line ID from the current table, while DAX text function MID from the column hierarchy path. If now identify the solid line manager ID by MID function, we leave it as blank. In my example, we have the 3 tiers. We need to copy and paste the DAX expressions 2 more times. By this phase with the .9 lineage hierarchy path column, we are able to create the column .9 low-level security field index by path contains DAX function, which enables us to judge if the look.9 email address by .9 manager ID is contained in the corresponding .9 hierarchy path or not. In the DAX formula, we first use the lookup value to identify .9 manager email address by .9 manager ID. Then place it into the path contains function to judge it by column .9 hierarchy path. This field index info will be used in security role creation. Copy the DAX expression and paste it to the notepad for later use. Step 3 is create the new role .9 manager group. In report view, choose modeling tab, click manage roles, create a new role and name it as a .9 manager group. In tables list, choose employee hierarchy table. In the field of table field DAX expression, paste the previous copied DAX expression of column .9 RLS field index. Replace the static .9 manager email address by user principal name. Please save. Now we have extended row-level security and column-level security for .9 managers. Let's have a quick test. Click View as pick in .9 manager group and other user. Enter the FC_AA email at test.com into other user field. By the view of manager FCC_AA, we can see all employee info. Stop the view and enter the .9 manager email address of FC_BB email at test.com. By the view of the .9 manager FCC_BB, we can see the sales and cost profit info of BB, DD, and EE. We may do some additional cross-user group test. Enter solid line manager BB into the .9 manager group. He cannot see anything. Thus, the .9 manager group is only limited to .9 management. After the testing, please do not forget to publish the file to service side and assign users to the new role and dataset level and workspace. For the details, please refer to suggested my previous video in my channel. Thanks for your watching, and please let me know your comments or if you have other alternative solutions for the business scenario. If you like watch more video from my channel, please press subscribe button in below. See you in next video. 2 years ago, I have shared a video regarding a method on how to use DAX formulas to create the combined row-level security and column-level security solution without external tool for an organization hierarchy, which has a mixed solid line manager and .9 manager. If you have no chance to watch the video, please refer to the link popped up in right top corner. I also attach the video links in this video description. In that shared Power BI report, due to the inflexible DAX formula to calculate the .9 manager path in the factor table employee hierarchy table, the solution has limitations to handle more than one .9 managers parallelly in an organization hierarchy. Such scenarios in my practice could be that we have different types of .9 managers in the organization hierarchy.
for example, financial controllers and HR managers, etc. They might be in same or even different layer to back up each other, and further the F&C can view all sales and cost related figures under his or her layer but not above. HR can view sales but not cost under his or her layer. To overcome the limitations on handling more than one .NET managers parallelly in organization hierarchy, I have modified the previous relevant DAX formulas and would like to share you the enhanced solution in this video. Okay, let's get started. First, let's add more different types of .NET managers in the dimension table, .NET hierarchy table, according to mentioned scenario. Let's add two additionally F&C managers, one as FC underline BB2 for the solid line manager BB level, one as FC CC2 for the line management CC level. Then add four HR managers for each solid line level, HRAA, HRBB, HRCC, and HRCC2. You can add more if you want, but for this demo, should cover our study scenario. Second step, simplify and modify the DAX calculated columns which are related to the .NET RLS field index calculation. In the fact table, employee hierarchy table, we only need to calculate the values of the column .NET hierarchy path for .NET RLS field index calculation. To calculate the values for the two columns, we can look up the .NET manager's ID and email address in dimension table .NET hierarchy table. Thus, we do not need the calculated columns .NET manager's ID and the column .NET manager's email address. Let's remove them. In the column .NET hierarchy path, the purpose is to use the solid line manager ID inside the employee ID list of the column lineager hierarchy path to map out and find the .NET manager ID in a hierarchy path pattern through the linkage between the solid line manager ID and the .NET manager ID in dimension table .NET hierarchy table. As the previous DAX formula was using DAX text function MID and only able to identify 4-digit employee ID and handle 3 layers hierarchy path. Thus the formula is inflexible and on dynamic implementation way. Thus we need to improve the formula and let it be more flexible to handle more complex scenario regarding the employee ID digit numbers, hierarchy layers numbers, etc. Let's use the content string and the concatenate text function to modify the formula. Keep the column name as it was. Define variable current solid manager ID to store the manager ID from the current fact table, employee hierarchy table. Define the variable hierarchy path to store the hierarchy path from the current fact table. Define the variable .NET manager IDs to filter the .NET hierarchy table and only include the rows where the hierarchy path contains the solid .NET manager ID from each row. Now return by function concatenate text to concatenate the .NET manager ID from the filtered .NET manager IDs table using the separator symbol. So the code finally finds the .NET manager's IDs based on our conditions and concatenating them into a single string separated by separated symbol. This is what we want in a dynamic and flexible way. DAX makes a magic here again. Now come to the last column, .9 RLS field index. In the DAX formula, as we have removed the columns .9 manager ID and .9 manager email address from the current table. Thus, let's turn to the dimension table with the DAX function pathContain to check if the value in the column .9 manager path contains the .9 manager ID, which is associated with the input email address FCCBB2. Through looking up the linkage between .9 manager ID and .9 manager email address in the dimension table, .9 hierarchy table. So far, the DAX formula modifications should be okay now. Copy the DAX formula for later use. Let's use the created DAX formula to fix the errors and the security field expression while managing roles and do testing to see if the enhanced solution can handle more complex scenarios properly. Back to the report view, choose Modeling tab, click the Manager Role icon. In Manager Role tab, create a new user group, .9 RLS and CLS user group, which we shall test the combined RLS and CLS for .9 manager user group, such as HR managers. With the created .9 RLS and CLS user group, select the cost table. Click button Switch to DAX Editor. Place in the DAX formula is blank index. This will block the cost info visibility for this group. Stay with the new created user group. Select the table, Employee Hierarchy table. Click Switch to DAX Editor. Paste the previous copied DAX formula from Factor Table column .9 RLS field index. Replace the specific input email address by user principal name. Now choose .9 manager group. For clean name, changing the name as a .9 RLS user group. For cost table, the visibility should not be blocked. Then select Employee Hierarchy table. Replace the DAX formula by the copied DAX formula in .9 RLS/CLS user group and save it. Last, let's do some clean works on the names for rest each user group. Modify the name of the user group RLS hierarchy user group as a solid line RLS user group. Modify the name of the user group RLS and CLS hierarchy user group as a solid line RLS and CLS user group. We can start our verify testing now. Go to Report View, click Modeling, click View As. Check report visibility of the .9 RLS with more F&C managers in the user group .9 RLS user group. At top level, FCAA test.com. Yes, he or she can view all employees' info. And same level, FCBB test.com. FCBB2 test.com. They say same level employee info. Then check the .9 combined RLS and CLS with more HR managers in user group .9 RLS and CLS user group. And top level, HRAA test.com. He or she see all employees' sales info only. At same level, HRCC hrcc2test.com and hrcc2test.com. They say same info, but only their labels employee info regarding sales. We get our expected result with these modifications. Please do not forget to save and publish the report to Power BI service side. Adding users into those predefined specific user groups at the dataset level with a security setting. Adding user email address to the service-side workspace with vulnerable access permission. How to do the setting in details, please refer to my previous published video, which the link is popped up in the top right corner, and also attached in this video descriptions. That is all about in this video. Please let me know your comments or if you have any other suggestion or different approach to improve this solution. Thanks for watching. If you like to watch more videos from my channel, please press the subscribe button. See you in next video.